Hi, I'm Lindsay Strapolo,
And I'm Grace Powell.
and today we will be talking about the atomic line spectra.
A line spectrum is the emission of light only at specific wavelengths.
Now I will demonstrate what that means. So, the gas being studied begins in the discharge tube, which contains two electrodes, which are very high voltage. As the electrons move from the negative electrode to the positive electrode, they collide with the gas particles. This collision results in the emission of light.
Why don't you draw that light for us, Lindsay? The light is then channeled through a slit. Why don't you draw that slit for us? And the light that is funneled through that slit then hits the prism. The prism separates the light into its components, like this. And then when the light hits the photographic plates, it is shown as this.
Why does this happen, Grace?
We use this to identify elements by their unique emission spectrums.
Okay, next on the topic list, we are going to talk about the Rydberg equation. Now, as shown, Rydberg equation is 1 over wavelength equals Rydberg's constant, which is 1.097 times 10 to the 7th meters to the negative 1, times 1 over n1 squared minus 1 over n2 squared. Now, I'm going to do an example problem. Grace, what two constant or n values should I use for?
Maybe 99 and 100.
Okay, so n1 will be 99 and n2 will be 100?
Yep.
Okay, so let's solve. 7, which is the constant.
Can we play some music while she's doing this work?
Now I'll get my handy dandy calculator. The Rydberg equation not only calculates visible wavelengths, but those of all hydrogens' spectral lines.
So now we'll talk about the Balmer series. The Balmer series is specifically for hydrogen, and it shows the 4 visible light, which is red, blue, indigo, and purple. Due to the lack of proper colors, I had to improvise. So the Balmer series is formed when the electrons go from a higher shell to n equals 2, or the second shell, and then the electrons experience like a burst of energy and emit light at these specific values.
This video is brought to you by Cosmos Balmer series.
Our textbook,
Slide Player, the Quantum Mechanical Atom.
and our textbook is McGraw-Hill.